All right. So, yeah, we are Air Devils. We are the AIAA Design, Build, Fly competition team here at Arizona State University. Every year we design, build, and fly a new RC scale aircraft to compete in the AIAA's competition. This year it will be taking place in Tucson, Arizona in mid to late April. Hopefully in person, but that is still being decided. We will know more in the near future as they tell us. But this year's competition is to design, build, and fly a UAV with a sensor suite. It is supposed to transport a sensor in a shipping container, deploy that sensor mid-flight, operate the sensor, and recover it before landing. Our aircraft are generally about 5 feet, generally less than 20 pounds, 5 feet wingspan. And yeah, this year's competition necessitates a lot of finicky mechanical devices, such as a bomb bay, a retraction and deployment mechanism, and a lot of flexible structural work to fit in the contradictory statements of fit a lot of sensors, but also go fast at competition. So we have been hard at work trying to encompass all of those requirements into a single cohesive airframe. And in order to do that, we have been doing a lot of design synthesis with spreadsheets, trying to better estimate our aircraft's performance and size our aircraft before we actually build it. We have also done a lot of aerodynamic work in trying to design the best wing for our aircraft. That was me and Evan Barkers and Derek Stratton, who's not here with us right now. But this was our graduate class project in the Advanced Aerodynamics class, MAE 564, I'm pretty sure. Hopefully okay, this code has finished and I can show off some of what this is. So here you can see the approximate stall characteristics of this aircraft as we get into high alpha. So we've done a lot of work to try and get this as smooth as it is with a, this graph is broken, but it looks pretty good of a good aerodynamic efficiency across the aircraft, which this is approximately what it should be. And so we're pretty proud of that. So this is our work that we've been doing so far on the airframe. We still have a lot of work to go in terms of actually finishing up the retraction mechanism right here. We have to finish up the bomb bay doors, and we of course have to build this thing, which requires a lot of laser cutting and 3D printing, maybe even some carbon fiber composite work in order to get all these pieces to fit together correctly and create a living, breathing, flying aircraft that doesn't breathe, hopefully. That'd be really weird if their aircraft did breathe. So we've been hard at work trying to put together our airplane. For reference, this was the CAD model of our completed 2019 or 2020 aircraft. It has a few model errors in the CAD just because of the version change between last year and this year's model of SolidWorks. But other than that, yeah. Here is something I've been working on recently. It is a model of our new sensor. We got a change in the rules that was communicated to us, indicating that the sensor design was not what we thought it would be. And as such, we have been forced to change what our sensor looks like. And this has been, I've been working on this quite a bit today, but it seems to be going pretty well. And I think it'll work out for having a stable design that is able to carry a bunch of stuff. There is a hollow back section that we can fill with weights and our sensor equipment. It has a towing point, fins for stability, that kind of thing. Yeah, our to get in sort of the brass tacks of what our meetings are like, this semester we'll be doing a lot of construction as safe as we can in outdoor environments, assembling the aircraft from parts that we're going to have individuals go and get some work done on campus. Like, for example, all of these side panels will be laser cut on campus at the laser cut lab, basically. That is over by ECG. It's also where you can get 3D prints done. And so we're going to laser cut all these panels and then fit them together, sort of like a advanced Lincoln Logs or Lego set, basically. Yeah, that'll be a lot of fine labor to get all these parts to fit correctly, but that's what this club is all about. Once we have that done, and the wing as well also needs to be assembled. It'll look something like this wing, where we have a central torque box that then has airfoil pieces acting as formers for our design. We will cover it all in plastic sheeting, and we'll have a competition-ready aircraft. Of course, that's the ideal situation. In reality, we'll have to do probably a lot of fine-tuning and adjustments of this design as we go on in order to correct any mistakes that we find out in assembly, as well as fine-tuning the working parts of this aircraft, such as the drum mechanism here is a part that's probably going to see a few revisions between now and when we actually go to competition, as well as making sure that this bomb bay down here works every time, because if it doesn't, then I'll be very sad at competition. Are there any questions? All right. So, I think Max and Evan Barker, have you guys been working on the catting up the wing design, getting it from this shape into like a better shape with ribs and stuff?
Talking to me about the wing?
Yeah.
Yeah, haven't gotten to that yet.
Yeah, I never got into it over break.
Gotcha.
One second, I can see if I can get Nick's code up.
Yeah. Our former president wrote a piece of code for us that will allow us to transform this amorphous, weird-looking wing body shape into a optimized profile that looks like this thing, with different material ribs for different loads that it needs. And so that's what we've been doing very recently.
Jack, are you working on Nick's code?
I've done some work on it earlier, so I definitely can help with that.
Okay.
Yes, it does seem a little bit broken at the moment.
That's broken me here. Yeah. We'll meet up with you about that outside of the meeting.
Okay. And the question about the ribs at the end, they are the control surfaces, so they're attached with hinges.
Yeah, these pieces are ailerons and elevator and rudder, respectively. And
I see.
yeah, so they are broken off, but that's because there is pieces that go there that we then hook onto the wing with small hinges.
Nice.
Yeah. Another thing that we kind of need to do for this sensor container thing is we need to design the cargo container for it that needs to protect it from a 10-inch drop on all 6 sides. 1, 2, 3, 4, 5, 6, like a cube. That should be fairly simple. Can be as simple as a cardboard box, but it should be also very compact because we need to fit a whole bunch of them inside of the aircraft. I'm thinking hopefully we can fit 6 inside, depending on how exactly the aircraft ends up being on internal space. One thing to note is that there was also another change in the rules. I initially gave dimensions for this aircraft based on the fact that I assumed that we were allowed to have external stores, like payloads on the wings, like bombs. But that was something that was released in the Q&A, is that all stores must be internal. So it makes our job a little bit easier in that we don't have to design like an aerodynamic cargo container for our stores, our electronic sensors, but it also means that it's a little bit harder to actually fit a good amount of stores inside the aircraft.
Hey, Daniel.
Yeah.
Are the bomb bay doors going to extend all the way back to the drum, or is it really just going to be the sensor?
It'll only just be this central bay area.
Okay, so I think my dimensions will have to change then.
Yeah.
What the second bay could be as well, because remember we're moving the drum up to the front.
Yeah, we're gonna move the drum up to the front, but it also will reduce our complexity a lot if we just have like a simple container here, like maybe a hatch or something that we can open up,
Oh yeah,
throw sensors in, close.
yeah.
It doesn't need to be as complicated as the actual full bomb bay.
Okay, and then is there room in the fuselage to put that servo that's going to be opening and closing the doors?
Yeah, there should be enough room forward of this bulkhead. One thing I need to do actually is throw in the batteries into this CAD model, just so we can get a approximate location for them, so we don't end up accidentally occupying the space for the batteries with, say, the retraction mechanism, deployment retraction mechanism. Because Ivan, correct me if I'm wrong, but the batteries go up on top here.
I don't really know. They could go anywhere since the whole deck, the deck goes all over the plane, so we can move it for balancing.
Yeah. Like we could even put batteries here underneath the wing box.
Okay, I found Nick's code, so I can show that off for a second.
Sure.
Right now I have the batteries like in the nose.
Okay.
So.
All right, so here is Nick's code. It's just a MATLAB code, and so what it's doing is it's given some parameters of the wing. These are input, some material strengths, the weight of the plane. It is calculating where the ribs, the structural ribs, are needed, and so this is a right here a top-down view of the wing. So this is the center line, and so it'd be like rib there, rib there, rib there, rib there. And so that, and then it also tells you the torque box dimensions. And then with that, we can, that is the lightest weight, structurally sound. It also gives some other, like how much it will deflect and the forces in it. And so using this, we are able to position both the ribs and how many we need. And as you see, there's only 4 here, when the previous one had a whole bunch more. In the previous year's plane, some of the ribs were not structural. They were just more or less cosmetic to keep the form of the wing. And so we'll be doing the same thing this year. where we have some structural ribs and a structural torque box and some cosmetic ribs.
Yep. And another change I kind of want to make this year is equipping our aircraft with a 3D printed leading edge in order to enable us to better build the aircraft, because one of the most labor intensive parts of the aircraft last year was applying on the leading edge to the wing. That was a very labor intensive process, a lot of waiting too. And if we can just 3D print something to go over the front instead of something a bit more involved like hot forming balsa, then that should work out. So yeah, that is our current plans. If you have any, like if you have a preference on what sort of project you'd like to, which part of the project you'd like to participate in, just shout out inside our Slack group. I'll go ahead and copy a new invite link. There are a bunch of different channels inside of our Slack for the different groups that are working right now. And yeah, it's the best way to get involved with the club is to participate on a project. So highly recommend that. Yeah, that's about everything I have to talk about for this meeting. So, all right, any questions, comments, or concerns? Let me know.